After my welcoming words, we will have a very nice keynote that summarizes the efforts that are done on demand responsive transport. This will be done by Lydia Senior from UITP, the representation of transport, public transport providers. And from there, we are switching to the Dynaxibility4CE project. That is the project that has organized this webinar and invited this MECA project. And there we will have a short presentation about the Schulwald study, that is a peri-urban region around Stuttgart. And then we will get some updates about the DRT implementation in Leipzig in Germany. From then on, we are going to the SMECA project, and they are going to briefly introduce what the project is all about. And then we will get examples from the Emilia-Romagna region from Giuseppe from SRM Bologna. And he will give the floor to Tamas from BKK, who is presenting the Budapest solutions concerning DRT. And then I will wrap up everything very briefly. So how did this cooperation came together? We have a couple of commonalities. We are both Interreg Central Europe funded projects, as you can see in our logos. So, and on the right, you can get a overview what Central Europe is, according to Interreg at least. And we are both looking at demand responsive transport. And we both have very interesting pilots from across the Central European region in our pockets, basically. And we would like to promote these digital solutions because we think that this could be a great solution for many cities, and something that will support public transport in suburban or peri-urban areas. And we think that this is a great timing because DRT is not such a big topic at the moment, and we would like to promote this a little bit. And therefore, I will give the floor to Lydia.
Nice introduction, indeed. We see a lot of potential in this kind of solution. So thank you for inviting me as keynote speaker today to this webinar dedicated to DRT, demand responsive transport, or delivering renewed public transport. I try to put it in a different way. I'm the Combined Mobility Manager at UITP. I'm an urban mobility planner by training, and today I'll try to give you an overview into this topic. So let me see. Yes, moving. Very good. All right. First of all, let me tell you from where I'm talking. So UITP is in the International Association of Public Transport. It's been there for more than 136 years. And it's a big association worldwide, like with 1,900 members. As you can see, not only operators, also authority, also members of industry, also technology providers with DRT and so on. So there's a lot of players in the associations. And with those members, what do we do? Let me put it in animation there. Well, some of them, they access working bodies, as we call them, or committees, and the manager of two of them, one called Combined Mobility and one on taxi and ride hailing. So with those members, that basically they cover all kinds of services that are not the classic public transport. With all of them, I try to have conversation, best practices, and I try to put everything in papers, as you can see those two examples there. So we are running actually a working group on DRT, and this is from where I'm going to talk today and give you a little bit of a flavor of what's going on in the world and also what we have learned so far. So let me move. So what is DRT? Okay, well, DRT is not new. So first thing to say, you can perhaps visualize it as a minibus or a van that adjusts the route and the schedule to the explicit demand of user. But if today perhaps you see it is possible via an app and thanks to powerful algorithms, well, the concept itself of DRT is not new. It's been serving millions of people, as you can see in that table, around the world for decades. For example, there you can see that many are coming from the US, because since 1990, they have a legal obligation to set up DRT services or paratransit. There are many names for it, especially for people with disabilities. So the concept is there, but as an expert put it once, now before it was a nice to have feature in public transport, and now it's a must have. It has become something very much needed because it has benefits. So let me perhaps move, if it's possible, with the animations. Yeah, there. So as I said, it was limited, and now what is new is technology, of course, but not only that, that allows better economics, that creates partnerships actually, and that allow this DRT solutions with an S, we're going to see it, to actually be applied to many different use cases to grow mainstream and to be more integrated into the wider public transport network. So this is what's new, and this is what we're going to talk about. Now, briefly, where it is. So we're talking about this. Okay, where it is. Very good. So I'm taking this information from an expert that compiled them in October, as you can see. So nowadays there are 45, well, nowadays October, 45 projects running around the world on 5 continents, you can see, but mostly Asia, North America, and Europe. There we go. You have a map, so you really see on 5 continents, but you also see for the colors that there are regional players. So players that are more insisting in certain areas. For example, DD is dominating China and around, but also developing other continents. And also an evolution that we see in the last years is that those services, they started many as B2C, so directly to the user, and gradually, well, very quickly actually, they went into a B2G, meaning that they work with authorities, operators, and so on. So more towards the government. So they became more technology providers working in partnership with authorities. And one point of attention here is that this is growing so much also during the COVID for many reasons, but there are many pilots. So it's not a stable picture, it's gonna change. So keep that in mind. Yeah, so what do we need a DRT for? But actually, as I was saying, there are many solutions. It can be many different things, as you can see in this complex table here with different characteristics. So that is one thing. And what for is basically use cases that I was mentioning. It could be, we're gonna see 2 examples late after this, but it can be many different things. It can be night service, or it can be to serve hubs and train stations, first, last mile. It can substitute a bus, for example, in the peri-urban area, or it can be point to point. So it's very many different use cases. And since there are pilots, many are gonna come even more. And let me get straight into examples. I have 2 examples for you, one from Berlin, Europe, and one from Dallas in US. They are not pilots. They've been there for a few years, and they are big developments. So about Berlin, for those that know this service, Berkoning, you can see it's a van. You see it in the picture in the middle. It's a van that is accessible to wheelchair. It's electric. And there are many of them, hundreds of them. They cover a space that is roughly 10 kilometers per 7, which include the center and around the eastern part, around the center of Berlin. And it runs during the night and weekend. So is that kind of service very popular? The branding is very strong, the marketing, and also because that branding and marketing is done by BVG, the operator, in partnership with Diavan, that is a technology provider, but doing much more than technology, as you can see in the slide. And let me see if I marked all the bullet points. Yes, so this is something that is running since 2018. And of course, that changed during COVID, but continued. So that's a very important development. And you see an example. The other one, the Dallas one, is very different. Again, this is done by minibuses and taxis, but those are dedicated provider. And then they have agreements with non-dedicated providers, such as Uber, for example. They they succeeded in getting to work with them, and local taxis. They cover a space that can be like in the map 65 kilometers, so it's very different, but they don't cover it all. They have dedicated zones of around 5 kilometers diameter. And so they cover those areas, and their use case is first and last mile to transport hubs. So that's what they want, and they run during the day. So it's a very different use case for that. And why they want to Uber, as you can see there, is because they wanted to grow actually. Because there's you're going to see there's many parameters that you need to figure out in terms of how many vehicles, when the time of response, if you want a short time of response, you need perhaps more vehicles and so on. So in the equation, they wanted to expand and grow. And the easiest also in terms of cost was to have a partnership with Uber and taxis. So you see very different examples. So what have we learned so far? Let me start very briefly with something high level, policy level. Many times when we talk about DRT, we talk about peri-urban areas, low density, rural. Very good. We've done a little bit of exploration of this topic. By the way, I think it's going to be published today. So watch the space of UITP, you're going to see it. But what I want to say in relation to DRT is that clearly we see it as part of the solution to bring mobility to those spaces, as you can see in this nice graph that comes from ITF. They also did the job on that. But what's happening when we look at those spaces is that basically they've been underlooked. They don't have resources, not only funding, but they miss a policy that is very much covering mobility in those spaces. There are many things lacking. There's need of technical assistance, as supportive regulation, and so on. So when we look at that, if you want those pilots to stay and provide benefits to those people, we need to change the framework for rural and peri-urban spaces. So this is very important. If not, those pilots will remain pilots. So that is something very important I'd like to put there. And another clear learning that we got from people that they implemented these services, that they are complex. They look like small, okay, it's a small thing, but it is not. It's a complex project that require change management, require to talk with external and internal people to accompany them in the change. The change, because of technology, can be very quick, so quick that the human don't follow. So you have people don't understand, or drivers. So really, there's a change management skills there that need to put in place to have those services set up. If not, the pilot will come back and then they won't continue. So very much there's a need for skills. Technology is very important, and the partners that can help you to drive that technology to what you want to solve as a problem. And I want us to 2 points. Economics are very different from classic public transport. If you get a metro or a bus, they have a fixed route and schedule, so the costs are fixed. Okay, no matter who is using it, it's fixed. But with DRT, it only runs when somebody is asking it. So it's variable. It's very variable. That means if they are successful, and usually they are successful, there are many people, well, the costs are going to increase. So fixing the costs, it's something very, very important. And this is why a key success factor is very much to go slowly. So progressive deployments and adapt over time. And this is why in my last 2 slides, I focus more on the going down, on the planning and implementation. And what I want to tell you, you see there are circles, okay? This is why there are circles, because you need to adjust all the time. And what is very important when you do some kind of agile planning and implementation is that you need to have your clear objective set, your use case set. What is the problem you're trying to solve? And according to those parameters that you fix, then you can adjust. That's very important. So that is, of course, I won't hide the fact that it is a complex dilemma, as you can see here, but also I'm going to tell you that in the next presentation, you're going to hear more about this dilemma complexity, this challenge. And I stop here, and I thank you very much for your attention.
And I would like to give the floor now to Nadine Müller, who is presenting Dynaxibility and the Stuttgart case. And we basically have initiated Dynaxibility nearly 2 years ago, and Stuttgart basically has created a study of the Schurwald area, which, as I've mentioned, is in the east of the city of Stuttgart. And I will give the floor now to Nadine. Please start.
So good morning, everyone. My name is Nadine Müller. I'm a regional transport planner at the Regional Association of Stuttgart. In general, we are responsible for spatial planning in the region of Stuttgart. And when it comes to transport, we are responsible for developing the suburban train line. And therefore, we also found it very interesting to be a partner of the Interreg Central Europe project Dynaxibility4CE, because we wanted to find out more about what would happen within Stuttgart region, and especially within a peri-urban area in Stuttgart region, if we would simulate to integrate autonomous ride-sharing vehicles that would be kind of a feeder to our suburban train lines. So we had the chance to participate within this project and do kind of a traffic model simulation, which I will present you now. Yeah, just very briefly, the structure of today's presentation. I will give an overview of the project Dynaxibility in general. Then I will head over to our traffic model study, explain the scenarios that we examined, and last but not least, show off the main highlights. Dynaxibility, like in very brief words, focuses on low carbon mobility and air quality priority. The duration of this project is 2 years. So we started in March 2020, and we will finalize the project in May this year. Altogether, we are 11 partners from 7 countries within this project. And the main outputs that we are reaching within this project are guidelines, strategies, and action plans that are focusing on 3 main topics within mobility, and especially within innovative and flexible mobility solutions. So we got mobility as a service, connected and automated driving, and urban vehicles access regulations. And we, as the Regional Association of Stuttgart, focused on connected and automated driving. First of all, the ground base for our traffic model study that we did within a peri-urban area called Schurwald region is our regional traffic model that we got within the software PTV Visum. Within the software, the University of Stuttgart, which we conducted as a service provider, analyzed the integration of autonomous on-demand ride-sharing vehicles that are functioning as feeders. And we integrated these feeders into our public transport system. And then we saw within different scenarios, which are the potential impacts, which optimization approaches could we choose, and so on. Like within this slide, I would love to give you an overview of the region of Stuttgart. This is a simulation of an exemplary working day. So you can see within these red dots that are moving around, and by the time in the right corner, that is showing 1 day, that we got a huge traffic volume within Stuttgart region. So we got about 9 million trips done every day. And you also see very well in the middle, we got the center of Baden-Württemberg, Stuttgart, and in the east to the center, we got the Schurwald area. This is also our planning area. And you also see quite well within this overview, our regional access to the middle centers. Just to give you an overview of our region. Now I will head over to the research area in particular. So our research area is a peri-urban area called Schurwald. It got about 50,000 inhabitants and is located in the east of the capital of Baden-Württemberg, of Stuttgart. In the status quo, there are operating 25 regular bus lines in this area, which is not that bad. But still, these bus lines are not like operating in every kind of this peri-urban area because it's very densely populated, of course. In the first step, to scroll down from our regional scope to our research area scope, we needed to do a microscopic adaptation of our regional traffic model. And then we examined different scenarios, which I will explain in the next slide. So here again, you can see a screenshot out of our planning area. In yellow, you can see the traffic cells that are like summarizing our planning area, the Schurwald. And in the north and in the south, you can see that there are train lines, and these train lines are the ones that we want to feed the people to with our ride-sharing simulations. So we want to increase the usage of the PT and especially of the suburban train lines. The scenarios that we choose to examine within the study, first of all, we get a base scenario, of course, which we are always comparing the other ones to, because then we can see what changed from scenario to scenario. In the first scenario, we integrated ride-sharing shuttles into the public transport, and we like completely left out all the regular bus lines that you saw before. And we said that these ride-sharing shuttles are operating in a 15 minutes service frequency, and they are picking up the people from the regular bus stations that are already existing in the planning area, and then feeding them to the train stations or to other places within the planning area. In the second scenario, we assumed the same, but with the difference of the picking up spot. So we said that the people are not picked up at the regular bus stations, but at their place of choice. So we got even a higher spatial area where we are driving around and giving the people a very attractive transport offer. And in the last simulation, we did kind of a combination out of 3 regular bus lines and ride-sharing shuttles that are operating not in 15 minutes, but in a 30 minutes service frequency. And again, the people are picked up at the regular bus stations that are already existing. And these scenarios were also assumed by other things, of course. So we choose that when it comes to the tariff, our offer is totally integrated into the PT. So the passengers pay the same price as for the rest of the public transport. When it comes to the ride-sharing vehicles in particular, we assumed that they got a capacity of 6 passengers so that they can bundle the trips. They are driving autonomously. The driving speed is equivalent to the regular vehicles. This is a thing that is needed not to create artificial resistance within the transport model. And when it comes to the transfer times for the ride-sharing vehicles to switch over to the rail transport, we said that the people get a transfer walking time of about 3 minutes, and the waiting time or buffer time is 5 minutes. Within this slide, you can see a screenshot out of the traffic model. So you see that in scenario 1 and 2, the blue traffic cells, there are living the people that are picked up by the ride-sharing shuttles and bring to these train stations in the north and in the south. And the yellow traffic cells are the ones that are still picked up by the regular bus lines, due to the fact that these traffic cells are right at the margin of our planning area, and they are better picked up by the regular buses because they are already driving there. And in scenario 3, we kept in 3 regular bus lines and did the combination out of bus and ride sharing. And here again, you can see that the blue traffic cells are these ones where the population is picked up by the ride sharing shuttle, and the yellow ones by the regular bus lines, just to give you a visual insight into our simulation. So what are the main results and main highlights of our study? Like very briefly, we are responsible for spatial planning. So for us, it's very important to increase mobility, not just in urban areas, but also in peri-urban and rural areas. So with that simulation, we showed that we implemented a very broad and attractive transport offer for the people in the Schurwald area, which is great. We also see positive effects on the share of the public transport when we have a look at the modal split. So we shift a lot of people from the private car usage to the public transport usage due to these attractive service frequencies in the ride-sharing shuttles. But on the other hand, our transport simulation is that attractive that we increase the total driven distance. So in total, we increase more traffic. But here it's the question, if this is also for a good reason, because we shift to the public transport. So when it comes to the occupancy rate, we get about 2 passengers that are riding with one of these autonomous ride-sharing vehicles, which is also an improvement when we compare it to our private car usage, because there in the region of Stuttgart, we got about 1.3 people using a private car. And the last 2 points, when it comes to costs and energy consumption, we are higher within these simulations because we need a lot of vehicles to do this service. And when it comes to the CO2 emissions, we have to say that they are more or less on the same level. So what do we have as an outlook out of this case study? For us, scenario 3 got the biggest potentials because it's kind of a moderate moderate and limited individualization, and still we get an increase in the public transport share when it comes to the modal split. But we still see reason for further research, maybe in spatial or time restriction. So this was it very briefly from my side. I know it's quite a lot. In case you got any questions, please contact me or feel free to ask. Thank you.
Thank you, Nadine. If you have further questions, please ask them in the Q&A section. We are going now to Leipzig, and I would like to give the floor to Carsten Schuld, who will present the DRT solutions of Leipzig.
I'm Carsten Schuld from Leipzig, and I would love to introduce you to Flexa, our own ever-growing demand-responsive transport pilot. As I learned by Lydia's talk, that we launched our initial service at the very peak back in 2019, where most of others did this in Europe. We've learned a lot in the meanwhile. Let me share some of our insights with you. But why are we interested in DRT? We do see 2 major trends out there. We do see digitalization and automated/autonomous driving approaching in some years. This, both by digitalization, we refer to having, let's say, a bidirectional informational pathway to you out in the field, the smartphone, where you can place orders and we can give you information and where to go to, and you could give us the information where you want to go to. Automated driving in conjunction with this might lead to several business cases, how traffic is handled. So on the one hand side, you have traffic as it is nowadays, and you could handle this traffic with different business models out there. They're already in the market. You could offer shared rides in a shared vehicle up in here. This would have impact on the traffic volume out on the streets. What you see here in those colors is are the results of a study back in 2017, where the traffic was modeled according to this business model and yielded outcomes on traffic volume or the parking situation. But I would love to see to show you only here the traffic volume. Another business model is you have an autonomous vehicle and you buy it and own it on your own, and it can get you everywhere. This would have this impact on the traffic volume out on our streets. Another model which we more and more favor is that you have rapid transit system as a backbone of your traffic, and this is complemented with feeder buses, feeder systems, shared feeder systems, and as is given here in green, it would, compared to now, yield a lower traffic volume. This is the path that we would love to go, and we have it. Most of the technology at our hand. We have rapid transit lines here in Leipzig. We self, as LVB, operate the tram lines and the buses. And the third thing you see here is something called Flexa, so those feeder services. And we tackle those challenges by 2 projects currently. We have a project called Absolute. It's focusing on technology of operating and implementing such automated / autonomous vehicles. And from that, so what we can take as a take-home message as now is that we as a public transport operator might be a good implementer on the way towards a highly automated vehicle, because we have local experience in the local operation of fleets, and if you teleoperate such automated vehicles, that could be a great way. On the other side, on the, let's say, on the user perspective, on the customer perspective, we have Flexa. That's the service already in operation, where we don't wait for autonomous vehicles yet. We are implementing the service that we have in mind already now, and both should be connected by this Dynaxibility project. So let's have a look what we have already in operation. Back in 2019, I already mentioned that we introduced our first service area in the north of Leipzig, a suburban area that belongs to Leipzig and was characterized by some bus lines meandering around and a lot of customer issues there. We rolled it out. We have until now more than 150,000 passengers there. We rolled out by the systems and virtual stops, 15,000 new connections out there. We have 120 such virtual stops. We have more than 10,000 active app registrations there. The virtual stops are placed that you have no more than 200 meters of walking distance to them. This entire system is deeply integrated in the PT system, means we apply the same fare system, at least in the pilot, so there's no additional fee. We have an integrated information system, so you ask for your trip itinerary, and it gives you an integrated route direction where you could, for example, step in your Flexa vehicle for the first mile, head over to a tram line or to a rapid transit system and go where your final destination is. Last year we implemented the second pilot in another area of Leipzig, but the really interesting part is ahead of us. We are facing pilot number 3 and 4, where and I'd love to refer to the use cases Lydia was showing you 20 minutes ago, where we want to substitute bus services. So far, we've already only implemented on top service in parallel to existing bus lines. Here in the southwest area, we would love to replace temporarily bus services. But of course, we have the problem there are remaining peak times where, for example, people go to school and return back home, where we have to stick with bus as a vehicle and bus line for some time of the day. However, we took the opportunity to straighten up and accelerate those lines and complement this with a fully flexible area-based DRT service. This is about to be introduced in September this year, and should be a major improvement out there, because as you would see on the left-hand side on this area, the entire area west of the train line has small streets and is not capable of having ordinary bus service there. So this will give a major improvement of the accessibility to our PT network. The other upcoming pilot is not that peripheral in Leipzig. It's more tightly connected to the inner center, but we have there a so-called neighborhood service. So that is a short line that runs every 20 minutes and brings you only to one connecting point where you can switch over to a connecting tram line, but no other line you can go there. That results in being this short bus line, being the lowest attractive line in the entire Leipzig lines. So it has the lowest number of passengers out there. We would love here to substitute the bus entirely, but again, we have this morning peak hour, and here we intend to switch from a fully flexible DRT service, switch with the same vehicles in a line mode for 1 or 2 hours. So that's another use case, and again, it should be introduced in September this year. With the Dynaxibility, we have a lot of things to tackle with. Lydia introduced you already. So it's finding out use cases, it's marketing, it's development of the software. You have to ask yourself, do you operate the vehicles and the driver yourself, or do you find a contractor for that? Lydia pointed out DRT itself is flexible, and demand could lead to adding up more and more vehicles. This is a really probable case. If you run with a contractor such concepts, then you have to ensure that you have this flexibility within your procurement and your contractors. Because with ordinary line basis, you have a very fixed set of operation, and you stick to that for years. With demand services, it could be that you have to adapt to the current needs and the current demand, and you should account for that with your contracts. Another point that we really gained on insights during the Dynaxibility project was the process of harvesting information from all our stakeholders, be it ourselves, for example, the traffic department or operations department, and our existing customers, our existing drivers, to improve the system and set out milestones for further development.
Carsten, please wrap up. You have 1 minute to go.
And here's my wrap-up slide. So we developed the software for DRT operation together with strong partners. We developed it mainly ourselves as a PT operator, and is therefore very well suited for PT integration. It is already integrated in the public transport system, as I pointed out. With the upcoming pilots, it will be even more integrated, because we will adopt our existing services in those areas to match up with the DRT services. And our long-term vision is to gain more insights in operating automated fleets, and therefore switch one day over to some killer-operated vehicles, and increase this ratio of operated vehicles per operator step by step, and therefore gain step by step from the automation on autonomous process. With that, I'd love to close. Thank you for your attention.
Yeah, thank you very much, Carsten. This wraps up our part for Dynaxibility4CE. And now I would like to give the floor to Giuseppe and Tamas from BKK and SRM Bologna, who will present the SMECR project and their results. Welcome on stage.
Thank you very much. I'm trying to share my screen. Okay. Okay, I hope you can hear me and you can see my screen.
Yes, okay.
Good morning, everyone. I'm Giuseppe Rigori from SRM Bologna. I'm the project leader of SMACR, and I work for the Public Transport Authority in the beautiful city of Bologna. Today, I will give you a brief introduction to the SMACR project. Then I will leave the floor to Tamas from BKK Budapest for the presentation of the pilot in Budapest, and then I will be back to you in order to show briefly some results of the pilot here in Bologna. So SMACR is the acronym of Soft Measurement Action for Behavioral Change and Knowledge to Embrace Peripheral and Rural Areas. It is a project funded by the Interreg Central Europe program with 2.1 million of budget. It was expected to be finished in the end of March 2022, but we received an extension of the project of 3 months, so we will end our activity in June 2022. The main objectives was related to the improving on planning and coordination of regional passenger transport in peripheral and rural areas in Central Europe. What we wanted to achieve, our main challenges were related to underused services and excessive costs, lack of proper services and proper intermodality, poor communication information, and also the above average use of car in the area addressed by the pilots. So with these goals in our mind, we promoted the demand responsive transport in the pilot area in order to connect these pilot areas with the main transport corridors and nodes. The SMACR approach was based mainly on 4 pillars. The first one is understanding, so we made analysis, best practice review, studies, and so on, thanks to 3 scientific partners inside the consortium, and then we share them with the key stakeholders and the project partners as well. The second pillar was based on participation. So we involved local stakeholders in local mobility forums that gave advice to project partners in order to implement the pilot at local level in a best way, in the best decided way. And also we involved external experts and external local authorities with a special program for them. The third pillar is the innovation pillar. We use the IT solution for our pilots, but we also innovate, introducing some marketing, some branding, nudging initiative that are quite new in the DRT operating modes till now. And the fourth pillar is the impact. We align our KPIs with CUMPs or other strategic plan at local level in order to get measurable results at the end of the pilots. So we implemented, we are running 6 pilots in our project, and our target were mainly residents, but is a common target for all the pilots, the residents in the area. But some of the pilots focused also on commuters, and some other on tourists. In Bologna, for the Bologna, we focus on commuters, on residents, and on tourists as well. These are a picture, an overview of the 6 pilot regions involved in the SMACR project. As expected outputs, we had trainings both at local and the international level. strategies, as well local, regional strategies and transnational strategies, pilot action, as already said, action plans in order to integrate peripheral areas using DRT, and guidelines and tools at the end of the project. We expect to publish these guidelines and tools by the end of April. The 6 pilot action we'll talk today about pilot action in Budapest and pilot action in Bologna. So I leave the floor to Tamás from Budapest in order to introduce the pilot from BKK.
Thank you, Giuseppe. Good morning, everybody. As previously mentioned, my name is Tamás Halmos. I'm working for BKK, the Public Transport Authority of Budapest. Just a very quick introduction about Budapest. This is the capital of Budapest. We have around 1.7 million inhabitants and further 1 million in the agglomeration. And the BKK as the Public Transport Authority and the Integrated Mobility Manager is responsible for all kinds of transportation within the city limits of Budapest, including, of course, the public transport network, where we are operating more than 200 bus lines, and we have around 5 million boardings every day. So this is quite a dense network. And we also have a quite high model share for public transport in Budapest. It's around 40 to 50%. Next slide, please. Okay. Yeah, as I mentioned, we have several, more than 200 bus lines. Most of them are operating on a regular timetable-based way. But we are operating also some lines as demand responsive ones, and as Lydia mentioned previously, the demand responsive transport is not a very new thing. We also operating a night bus line as partly demand responsive since 2006. For more than 15 years ago, we launched this kind of method, and we are also operating for around 10 years 5-day bus lines, partly demand responsive. These lines are serving the less dense areas. On the one hand, on the eastern side of Budapest, where they are connecting the suburban areas with railway stations. And on the other hand, we have 4 lines on the northwest area. It's just a hilly area with forests. So there are only just a few houses, and here also we are connecting the suburban railway. So the main network is connected here with demand responsive lines to the local inhabitants. Yep, next slide, please. Okay, and what did we do in SMACR project if we already had the demand responsive lines? Okay, they were working for a long time, but to request a service, it was quite complicated and inconvenient also for the passengers and for the operator as well. And it was not really possible to make more lines demand responsive because of the high human need from the operator side for register the request. So following the request of the passengers and our needs, we decided to develop an online service request tool where passengers can register directly to the service, and they can order the bus through their desktop computer or also through their mobile phone. So we developed the online tool. This is not an application. This is available in browser, but it's responsive, so it's very user-friendly also on smartphones. This is because we, in a later step, we would like to integrate it into our integrated application. So we decided not to develop a separate application, but make it open for the future to have an integrated solution for Budapest. This online tool has a front end, of course, also have a back end where the dispatchers can register the phone-based requests as well, because it was not really possible, and yeah, it wouldn't be a good idea to stop the possibility of call-based requests because of the elderly and the other people who are not really familiar with online systems. So we still have this option available, but the online request system was very popular. We will have a slide with the numbers of what is the share of the online requests. Next slide, please. Okay, and here are some steps. How did we plan and communicate the online request system? Because within SMACR project, we have learned that not only the technical solution that has to be made, it's also very important that it has to fulfill the need of passengers and also the operator, and to communicate it well. So we have organized 4 local mobility forums, 2 before the pilot, 1 during and 1 after. For these forums, we have invited bus drivers for these specific lines, the representatives of the area, and also experts from the university who are experts of DRT, and from the IT expert side who are developing the application, and from the operator side who is operating and working on the dispatcher center. So every stakeholders were there on these local mobility forums, and based on the discussions we had there, we could fine-tune the development, and and we saw that this is very important also to communicate well when this system is ready. So we printed several flyers and posters. It was available in the customer centers, on the bus stops, and also on the vehicles. And we had a lot of social media posts, and several Hungarian online newspaper was wrote an article about the new availability. So I guess it was quite well communicated, and every stakeholder was informed about the new opportunity. Next slide, please. And finally, some statistics about the usage. As I mentioned, we have 6 bus lines, so we didn't expect several thousands of users, but we had around 600 users who had registered to this online tool, and around half of the requests came through the online system. In the beginning, only a smaller amount, but in the last months of the 1-year-long pilot, around half of the requests came through this system. So people was happy with that, and they were talking about it with each other, and we had new consumers every month. And we received around 5,000 service requests through this online tool within the 1-year-long pilot. And based on the successfulity of the pilot, we decided to operate continuously this online request tool after SMACR project, or after the pilot as well. So it's still available, and we are thinking about the extension of demand responsive network, and also the integration of this tool to the BKK integrated mobile application. Thank you very much.
Thank you, Thomas. I take the floor. In order to present very short, the pilot in Bologna, it is called bus. That means by bus, but it's, remember, call by phone. It is the on-demand passenger and transport in the Bologna Apennines area. It is an area not very densely populated. It was first activated in 2018 outside the SMACR project, and then in SMACR we optimized the network, and also we endowed with an IT platform and that for management and booking. The area is full of touristic sites, and we wanted to serve them with 5 summer lines with flexible route and stops. We provided an on-demand bus services connecting the 2 main railways, the railways crossing the Apennines, and it was active on Saturdays and Sunday and public holidays from 8 a.m. to 8 p.m. from 6th of June to 12th September. It was requested a mandatory reservation via call center or via the app, and the costs of the operation was variable according to the number of activations. So we had the fixed cost for the app, and also the service was based on the number of activations. We made totally, we rebranded the service, and we made a communication event ad hoc in order to promote the service, both in the area, but also in the city of Bologna. We arranged some events in order to promote the service. We identified an IT provider through a market survey. It was the French company Padam for us. And this IT was useful for transport service operator in order to make the optimization of the routes, and also to make the real-time booking status to the driver. And it also allowed to insert the requests on the IT platform made by the call center that remained active during the pilot. For passengers and users, it was available in Android and iOS, but also the booking was possible via website, and the system informed the passenger on the real time of the arrival status of the bus. We had quite good number, but not good as expected, especially for one line. And after the result of the summer experience, we tried to improve our pilot action, and in the winter service, we changed totally the pilot. We made one service in one area of small villages, active from Monday to Saturday. So we changed the scheme on the week, not in the weekend, but in the weekdays, especially for residents in this case. And the second line was dedicated to tourists that wanted to reach the ski area in the top of the mountain around Porretta Terme. And it is arranged on Saturday and Sundays from December to March. What we learned from the SMACR approach, what we learned from the upgrading solution of piloting. Of course, we concentrated our effort to connect to the TNT network from to the local area, and to made available this possibility also for tourists and for residents. We also we had to develop this implementation with according to the people needs, and for this reason we established the local mobility forums that were very important for us in order to receive advice, to receive the needs coming from the local stakeholders. And also we made specific investment in order to innovate the service, to provide them with the IT solution, and also to make possible for people to enjoy their territory in an easier way. This is our lesson learned. The pilot are still ongoing. For some of the pilots are still ongoing, this SMACR project. So we will have our final event in May in Vienna, and so we will give our results, and I hope to see you there in person in Vienna for the final conference. Thank you very much.
Thank you very much, Giuseppe and Tamas. I will briefly have your attention because we are already a little bit over time. Let me share you our social media information that you should be able to see here on the screen. If you want to follow us, Dynaxibility on Twitter or on LinkedIn, just search for it. It's at Dynaxibility4CE, one word. And for LinkedIn, you have to search our project. And for SMACR, it is at CE SMACR. And for LinkedIn, you can find the abbreviation there, SMACR minus Interreg minus CE. And if you use the QR codes, you can go, you will be redirected directly to our homepages. Thank you very much for attending this webinar. And if you have further questions, you can approach us either via email or via social media.